Okay, hi everyone. Good morning, good afternoon, wherever you are at this moment. So we're gonna continue with the foundations of Golang programming, and today's session is gonna be the idea is trying to go deeper into the basic concepts that we were discussing last week. So the idea of today is not to show you any slides at all. The idea is to continue using VS Code, as you can see in my screen, and I'm gonna start coding a few things, and we can give it a try to a few things. So it's gonna be a lot of hands-on. Try not to, if you would like to follow along, um, uh, try to pay as much attention as you could to the things that I'm gonna be doing, because as Hussam was saying, this is gonna be recorded. So it's better you follow along later and pay as much attention as you could today. So I'm gonna do another thing. I'm gonna turn off my video because I want you to focus on the things that I'm gonna be doing in VS Code and not seeing my screen, my face at the moment when I'm coding, so that you can focus on one thing only. Then at the end of the session, I'm gonna be taking some questions. Hopefully, feel free to send them over while I'm interacting and I'm doing the things right now. And if something is not clear, be happy to make this a little bit an easier way to understand at the end. So let's get started. I'm gonna turn off my video now. So last week we were talking about a hello world, right? So the first thing that we did and we were talking about is that we need to work in a workspace. Every program that you create in Golang will share the same workspace, and the idea is that by default you create all of your projects in that directory. You can have custom workspaces, but at the end of the day, the idea is to use this one for the default one for now. And as you can see in my screen, I have this workspace open, which is basically where the code will live, right? We explain what bin, pkg, and source file, source directories are. And here is the project that I'm starting right now. As I said last week, I'm starting in a fresh computer, so you don't see any other code here other than the hello world that I created last week. And just as a recap from last week, you have here a hello world. We're gonna continue explaining what of these things are, especially the package thing that we discussed briefly last week. And just as a recap, there are a few commands that we need to run before we can start using this application, right? So if you remember last week, we need to, if we want to run the application, we have to use go run main go, and that's gonna be putting everything from, executing the program, and that will compile and it's gonna run the program that I'm creating, right? If I just want to build the binary, I just simply need to run this build, and this will create an executable. If I try to open this, this is not gonna be something that I can see. But if I run this, like slash, let me just switch my keyword here. For some reason, it's not this. Okay, main. So if I run it, this is a binary that I can take any other place, and it's gonna run. I don't have to have go installed to run this application, right? So that's basically the idea of a basic program and how a hello world will look like. Right, so we're gonna continue today on discussing 4 sections. Hopefully we have enough time that we can cover all of them in this hour. The first one is gonna be variables. The next one is gonna be data types, and the following one is gonna be functions. And I'm gonna spend some time talking about packages at the end of the session, which is gonna be pretty much like putting everything all of the pieces together, and we can see how we can integrate or work with other projects, not just this hello world, right? So the first thing that we need to know is that we can declare variables in this way. So the syntax for declaring variables, if you are familiar with C#, perhaps this is going to be something that you already know about how to declare a variable. In Golang, you have to use the var keyword. And then you can use any name for the variable, and then you have to specify the data type. We're going to talk about data types in a moment, right? But for now, this is basically the first thing, or the default way that you can use to declare a variable. So it's pretty simple, right? You just simply use the var keyword, the name of the variable, and the type of that variable. If you would like to declare more than one variable in one line, of course, I can have this one, right? I can have last name like this. It's going to be something like this, and right, and that's it, right? But if I want to have that in the same line, I just simply do something like this, and I can have two variables in that same line. So I can continue adding more variables here, like age, it's going to be int. Again, we haven't talked about data types yet, but this is a way of how you're gonna declare variables. Right. What if we would like to have kind of like a section of variables in Go, right? So we can have something like this. We can have var, and we have a section open here, and we can start declaring the variables in this way. So I'm gonna be here string. And I can have the other one is going to be age int, and it's going to be in this way. Notice something interesting that happened here, right? As soon as I hit save, the VS Code applied the format command to the program that I'm writing. So this is pretty nice and pretty convenient, because as I was saying the other day, if you are that type of programmer that likes to have this type of functions declared, in Go, they don't work. It doesn't work that way, right? Because as soon as you hit save, well, it should be formatting that code. Well, it's gonna give me an error here saying that I need to, unexpected semicolon or new line. It's not something that it likes it, right? It actually gives you an error. If I try to do something like spaces here or tabs or something like this, and I hit save, notice that Golang will always format that. So that's pretty convenient. All right, so now that I have here my variables, I can declare them. But what about if I want to declare them and I want to initialize them, right? So if I want to do that, I can do something like, again, notice what I'm gonna be doing here, right? VS Code is gonna start formatting my code, the code for me. So I'm gonna stay and do something like this, equals to, that's gonna be John, something like this, and I can remove the comma here, and I can have another initialization here, and that's gonna be John Doe, right? Doe. As soon as I hit save, notice that again, format gets applied. So I can initialize in this way the variables. If I want to initialize this other value, I have to do something like this, for example. And again, it's gonna follow the same standard. And notice one thing, I didn't have to specify the type of the variable because that was inferred from the value that I used to initialize. Actually, notice that if I hover over this, it says var first name. It actually shows you the type of variable that you're declaring, and I mean the name of the variable and its type, right? So you can see that this is gonna be an int, and if I do something like 32.2 or something like this, this is gonna change the type, right? So that's something pretty convenient. I guess that it's something that it exists already in other languages, right? But if you would like to have this initialization not infer the type, you can as well include the type here, and it's gonna be like this, and it's gonna be like this, and that's gonna be it, right? So it's gonna be int. And if I try to do something like this, if I include a string here, notice that it does let me save it, but it gives me a warning, right? Cannot use this because it doesn't belong to. So Golang is a strong type language. and you have to be really careful when declaring things like in this way if this is what you would like to do. So again, let's have another shortcut for this, and let's say that I would like to have again one section for this variables, and I would like to group those variables, but I would like to have them in one line, right? Those typical challenges that you see. Okay, do you know how to reduce lines of code? Well, you can instead of having 4 lines here, 5 lines here, I can have only 3 or 2 basically. So I can do something like this: first name, again, do something like last name, age, and I can initialize them, and I have to put the variables, the values, in the same order that I declare them. So it's going to be something like this. John, it's going to be Doe here, and notice that it's highlighting the variable that is still missing, right? So I can have this in this way. And that's pretty much how I would like to, I can declare variables, or the different ways that I can declare variables in Golang. So if I want to use them, I can simply reference them from here, right? First name, last name, age, and notice that if I hit save, again, formats the code, right? So I can have this, and if I run this, it's gonna print the values of those variables, okay? So that's pretty much convenient how you can declare variables and you can use them. And notice one thing, right? This is gonna be the scope of this variable. It's gonna be global. And if I try to declare and just simply cut this and include it here, and I save it here, the scope it's gonna be different. I'm not gonna go deeper into the scope because that's gonna be for another session in another time. But notice that I can just simply put this into the function that I would like to use them. If I try to access this from another function, it's not gonna be accessible. There's actually one last way, or one last thing that I would like to show you in how you can declare a variable, and this is gonna be the typical way of you seeing variables declared in Go. So if you don't want to use the var keyword, you can remove this keyword, and you can continue doing this, but you have to add a semicolon here, and that's it. So notice that you can also use semicolon equal here to declare a variable, and that's pretty much you're saying I'm declaring a variable and I'm initializing the variable right away. And I can continue using the same format, and that should be continue working, right? If I save it and I don't see any error in the screen, I'm pretty sure that this is gonna work, right? So if I run this, again, I have the same result. So that's pretty much all of the ways or typical ways that you're gonna have when declaring a variable, right? So the other thing that you can use in Go, or that you can have in Go, are constants. Constants, as you remember, are type of variables that are not gonna change its value during execution, but you have to initialize them with a variable, right? So you can have things like const. Well, by the way, the keyword to declare a constant, it's gonna be const. So you can have here the name of the constant, like status. Okay, here it's gonna be 200, and that's it. Notice that again, it declares the variable in this way, and you can see how it looks like, right? So it's declared and it's initialized. So again, I can reference that from the main program, and if I would like to do the same thing as I did with the var when declaring variables, I can do that with constants. So I can do something like this, open parentheses here, and I can have here a group of variables or constants that I would like to use. So for example, that's gonna be something like status, okay, it's gonna be 0, and I would like to use this one as status connection reset. It's gonna be one, for example, and that's going to be status other error, for example. That's going to be 2. Notice that again, formats the code, and I can still have access to that. If I do something like this, status OK, and I print it and I execute that program, notice that I have access to that, right? Status other error, and I save it. If I run it, again, I have access to that variable from this function. So that's pretty much what you can do with the current variables. There's actually one thing, I mean, you can see here that this is going to be pretty similar to other languages. If you are familiar with, for example, C#, you will notice that this is going to be similar to declaring enumerators or enums in this way, right? So there is a link that if we haven't shared yet, we're going to share over the chat, where you can get more of this information, because this content that I'm teaching today, it's a written content available for you to practice and read it slowly, in a slower way. And you can, if you go to that link and if you go to that reference, you are going to see that I'm referencing here one thing that is called in Golang called IOTA, so that I can infer those continuation values as if you were using Excel or something like that. But I'm not going to cover that in this session, because we need to cover a few other things, right? So that's one thing. And the other thing about variables that I wanted to share with you is that there's something that I mentioned last week, that Golang is very idiomatic and tries to force you in a way to have things that only the things that you're gonna be using. So for example, if you use, if you declare a variable here, and you have here, let's actually go back a little bit, and let's go back to this so that I don't type any of this again. So if I do something like this, I can use all the variables if I want to, and I can run this and it's gonna run, right? So nothing weird, nothing strange here. But what if I would like to, let's say I would like to take this variable, h variable, and I want to declare them only in the function. So if I do something like here, h colon equal 32, and if I try to save it, notice that I see something red being highlighted here, right? It says h declared but not used. So that means if you are declaring a variable within a function, you have to use it somewhere. Go doesn't like, it's very idiomatic in this way, it doesn't like to have unused variables declared, because again, you're going to be reserving at some memory that you're not going to end up using, right? Why should I be allowing you to declare a variable that you're not going to use? So even if I try to ignore that error and I run it, it's not going to compile. Go is very different from other programming languages, where it's going to throw you an error if you are not using a variable and you have declared it. This error goes away if I include it here, and again, it runs, right? So that's pretty much what I wanted to show you in regards of variables. And I think that this thing of about not compiling when you have unused variables, that's pretty convenient, right? All right, so we have covered the first section of today's session. It's gonna be that was variables. Then the next one, it's gonna be a short one, because I don't want to spend too much time on data types, because it is not something that it is that it does not exist in other programming languages, right? But in Golang, you have basically 4 categories for data types. The first one is going to be basic data types, things like numbers, strings, and booleans. The other category is going to be aggregate types that we can discuss in future sessions. It's going to be aggregate types, and they are called like arrays and structs. There's other category called the reference types, where we include in that category pointers, slices, maps, functions and channels. So even this function that you can see here, that could be a type. That's pretty interesting in Go. And the last thing that we're gonna cover maybe at the end of the module here, that is already included in the written content that I've been mentioning, it's gonna be the interface type. So you have an interface that is gonna be a data type as well. But today's session we're gonna cover only the basic types. So let's actually get rid of this, and let me show you here this one, right? So you have here, for example, a bar of its type that's going to be integer. You have this int, for example, int 8, and that's going to be this. That's going to indicate the size of the bits that you are going to be able to use. Ignore this error for a moment because again, I'm declaring it but not using it, right? So the other thing that you can have is that you can have integer 16. That's going to be int 16, and you can have a number that is going to be, for example, this long enough, right? 67, 66, 7. The other one that you can have here an integer of 32. And again, notice that I'm following a parent here. That's basically the number that I'm putting here is the number that I would like to use as a limit, as an upper limit for the variable. So if I try to do, let me just, I don't want to type that, right? So if I do something like this, notice that I have here, again, I have these errors. And if I do something like this, print line, notice, did you notice that, right? So as soon as I was removing that line and I hit save, VS Code removed that reference to the FMT package because I'm not using it anywhere, right? Again, that applies to the import as the same thing as applies to the variable. So if I do something like this print line, and I do here integer 8, and I hit save, notice that it includes the import and error goes away. If I do something like here integer 16, integer 32, and integer 64, notice that if I run this, I can see the values, right? I can use them, I can see the values there. So if I try to change something like here for a higher number, notice that Go throws me an alert here. It says that cannot use 128 because it's an int 8 value in variable. So that has a limit about the numbers that you can use. And again, that goes back to the bits and how many bits can store that variable depending on the value that you're using. So if I run this, again, I have here the error, and if I go back here, and you can see that the error goes away. So I can see that it is working, right? So I can do the same thing for here, changing just one number, right? That changes the size of the variable that it's gonna be using. Last thing that I want to show you is that if you don't specify this, it's gonna infer the value that you're gonna be using depending of the architecture of your computer or the server where you're running the application or compiling the application. It will interpret this just simply int as int 64 because my architecture is a 64-bit architecture. So if I run this, that should be working, right? So if I change this to a higher number, again, that breaks, right? Because if I run this, I can see that overflows int, because again, that is the same in my computer as if I do something like this. So that's something that you would like to have in mind for reference, and in case you see any type of these errors in something like this. So what you can also do here is like you can do operations for the data types that you're doing, right? So you can do something like this in type here, right? So that you will expect this to be working in a programming language, in a typical programming language, where you can actually sum or use two numbers that are similar, right? So in Go that doesn't happen because you have to cast them in explicitly. Cast doesn't work implicitly in Go, so you have to keep that in mind. If you want to do this type of operation, you have to convert that value first, right? So we're gonna type, we're gonna see that in a moment. So, but before I do that, I just want to show you here that there are other types that you can use. So ignore the number of the variable here for a moment, or you know what? Let's add a new one here. Let's use a new a variable here that is going to be float 32. That is going to be the type here, float 32, and that's going to be a number like this big, right? So you have here this number, and again that applies here. Use variables. If I run it here, perhaps this is not the best way of declaring a variable here. Let's actually use this one. So if I again try to do something like this, try to change it, I should have an error here. I guess that that's not the upper limit that I'm using here. So again, that works, and you can see that the output is different, right? So you can have here those type of things, those type of variables, integer numbers, floating numbers. You can have here, if I do something like this, remember that, right? So if I declare it and I save it, notice that it goes to float int. It is not gonna be a float. If I want to convert that to a float, I have to, for example, initialize them in this way, and that's gonna convert it to float 64. Again, float 64, it's because my computer is a 64-bit architecture. I can have another types of, those common variables, data types that you see in other languages, right? So I can have Boolean type, something like this. Feature flag, again, if I'm not using it, I have to use it, otherwise I have a warning. If I run it here, you can see here the value, it's this one, right? And just because I want to include it here and be explicit about it, we've been using the string types, right? So if I do something like, again, first name, it's gonna be this, and it's gonna be John here as well. This is gonna be string type, right? So if I do here, bars first name string. Again, those are the typical data types that you're gonna be using. There are not many data types that you have available in Go. But these are the common one, the most used one in any typical programming language, right? At least if you are starting right now. One thing that I want to show you here, and perhaps you are not expecting to see in programming languages other than Go, is that in Golang you don't have to initialize a variable if you don't want to. If I remove this, and if I remove this float, it's gonna be float 64. Notice that we don't have float, simply float, right? It's either float 64 or float 32. So if I do something like this, notice that I can still use it, and I don't have any evident error here. And what do you think will be the initial value of these variables? If we run it, in other programming languages, perhaps you're gonna see that you need to initialize a variable before you can actually use it. In Golang, that doesn't work that way. This doesn't work that way. So if I run it, notice what the default values are gonna be. For integer, for numbers, it's gonna be 0, and for Boolean types, it's gonna be false. And for string types, it's gonna be an empty string. You don't see it because it's not printed here, right? But if I do, if I change the order here, and if I run it here again, it's at least a little bit more evident that it printed something, right? That is an empty string, because by default, a string value has an empty value. So that's pretty good in Go. You don't have to initialize a variable if you don't want to, or if you don't need to start using it. So that's pretty much what I wanted to talk about. So let's go back. Let's go back here to our previous example about casting, right? So remember that what we did is what we were trying to do a few minutes ago is that we wanted to sum these two numbers, right? Integer 8, it's going to be plus integer 16, right? If I do here, this again, casting implicitly is not supported. Let's actually to use, there are built-in functions to do casting here, where you can do something like this, int 16, and I'm gonna cast that number into an integer 16. So that way I can use it and I can still have this, right? So if I try to have 127 and to something like this, and if I run it, I can see the value there, right? So I can see that it's working, that this line that I'm using where I need to sum two numbers, it's working, right? So that's pretty convenient if you would like to remember about it. Golang does not do implicit casting. You have to be explicit about it. One last thing that I wanted to highlight here is that there are going to be times where you are declaring a variable, or where a function is returning multiple variables, which is going to be something that we're going to discuss in a moment, where you can ignore some variables. So if I try to do something like this, and I do an underscore here, and I simply delete here, notice that I don't have any error here, right? So if there is going to be a variable that you would like to use to declare for some reason, but you don't want to use it or explicitly use it, I mean, you can still use it here, right? You can reference that, well, not in this way, but you can reference that that type of variables in not use them. That's going to make more sense when we're going to be discussing about functions in a moment, okay? So just to give you an example of this, let's say that we would like to convert this into again, numbers, right? Into something that we can sum here. So because even we haven't talked about functions, let's just talk about this, right? So you can have here an I variable, and I can have here, let's actually do it this way. There's a string, the built-in function from this package that I can use to convert that a string to a number, right? So I can have things, something like this, and I can do something like println I, right? I can have something like this, but notice that it's giving me an error. What's happening here? Cannot initialize one variable with two values. So because I already know about this function, and I'm gonna explain this in a moment, this function returns two values. It actually, you can see here the signature we're gonna talk about in a moment, that it returns an int and an error type variable. So if I want to ignore that value, I can simply use the underscore here, save it, and the error goes away. If I run it, that's still working, right? So you can ignore variables to prevent that error from compiling the application by using an underscore value. That's pretty much what I wanted to highlight in this moment, and that's gonna make more sense as we continue progressing throughout these modules, right? So the next topic that I would like to cover is going to be functions. And one of the things that I mentioned early is, or in the previous session from last week, is that every programming application, every application in Golang has a main function. At least those applications that we want to run, that we would like to execute in this way, that we want them to do something. That's why we have the package main. I already explained that. I explained that last week. And for if you have that package main, you have to have one main function that is going to be the starting point of your application. This is going to be the starting point. If I declare something here, if I declare a variable, a function here, main2 or main something or other name or other function name, that's not going to be the starting point unless I call it from here. So before I jumping into this, notice that there's a basic signature for declaring a function here. You have func main open and closing parentheses, right? So you have the func keyword to declare a function, and you have to explicitly include here the name of that function. So as you can see, I can call that function in this way, as I've been doing it in this way from calling this conversion, but I can create my own function. So if I want to actually encapsulate that logic here or the sum conversion here, and I want to do something like that, I can declare this function here like sum open parentheses, and I can declare here an open braces, close braces, and that's going to be the name of the function without any parameters, right? But if I'm expecting to sum two numbers, the way that you're gonna be expecting parameters here is that you have to put any name that you want here, number one, and then you have to specify that name. So in this case, it's gonna be a string, right? Then we're gonna have number two, and it's gonna be a string. So this function is gonna be receiving two string numbers, and it's gonna sum them, right? But if I do something like this, and I say that, for example, int one, it's gonna be, let's actually go back and use what I did here, right? So let's do something like this, a iota, a string to an integer. I do something like this, number one. I save it, and I do the same thing for a2, and I declare it, and I do something like this, number two, and I can at least do something like this, right? But the idea of this function is to return the summary of these two numbers, right? If I try to do something like this, return int one plus int two, that should be working, right? But I haven't indicated to this function what's going to be the return time, because the return time can be it can be optional, right? I can simply just use this function to do something like this, print, and I will simply try to print the sum of these numbers, and I can simply call it here sum, call it here like 42 plus it's going to be 3, right? So if I run it here, that's going to be pretty much, this is going to be printing the number, right? It's going to be doing something like this. It's going to be, I can do something like sum is like this, and I print it, and you can see sum is 45, right? But if I want this, instead of doing something like a void function in other programming languages, I can specify the name of the type of the return value that I want to use. So in this case, I will have to go back here to int one plus int two. So in this case, it's gonna be running a function here, and it's not gonna print something, right? Because I'm not printing something. So I'm gonna do something here, print line here, and I close it here, and it's gonna be sum, and I close parentheses here, And if I run it, okay, well, I do something like this again. Sum is like this, and I save it. I run it. Sum is 45. Okay, so I can specify here in the values that I would like to do. So let's imagine that I would like to do something. Another interesting here in Golang is that if you don't want to, if you can specify the name of that return value as well. You can do something like here result, and it's gonna be simply just applying here result to that the summary of that to that variable, because I can use it. But remember, I still need to return something. What should I be returning? If you can, another option in Go is to simply type here return, and that's gonna be it. Well, I'm initializing that variable, and I cannot initialize it because it's being initialized here, right? So I simply do something like this, and again, I can do I can continue using this variable, and I can name those return variables in the function here. The last thing that I would like to show you here is that you can actually return multiple values. So let's say that I would like to return not just the summary, but also the multiplier of this, right? So I can do something like this, mult, and I can do mult here. It's gonna be int 1 times int 2. And notice that now I have an error here, right? It says that it's expecting 2 values here. So you can have multiple values in a function, and you can specify here as many as you want, but you have to use them. So remember what I did previously, right? So I can see that I'm gonna be doing something like this. It's gonna be here. I have the sum, and I have the multiplier. I have here 2 variables, and I can do something like this, right? So this is gonna be the return first return value. It's gonna be assigned to the sum variable, and the other one, the mult, it's gonna be returned to the mul value. Again, I'm not using it, so that's why I'm having an error here. But if I try to fix this, and I do something like this, I can see that I have that it is working, and I can have multiple values here. And as I was saying before, right, if you want to ignore that value and you want to ignore that error, you can simply use the underscore here, and that should be working. All right, so that's going to be it for the function names and how you declare your own functions, and how you can declare a function with multiple values, right? So this is going to be, as long as you remember this signature for the functions, right? The func keyword, the name of the function, and then you simply specify as many parameters as you want to, and then with another parameter here with other parentheses, you declare the multiple return variables that you would like to use in this function. Last thing, but not least, for today's session, it's going to be about how can you start using packages, right? Let's say that I would like to start using this function instead of calling it sum. I want to call it calc, or do a calculation. That's going to be summaries and multiplications here. So let's say that I don't want to go back to having a program where I have hundreds and hundreds of lines, right? What if I want to encapsulate here or to refactor this? Perhaps someone else can use it and create a package here. So for this, we're gonna have I'm gonna try to cover this very briefly, but we can continue spending even 1 hour talking about packages, right? So I'm going to show you the way of working on this way, right? So the main package, as I was saying before, is the one that you're going to be using for your executable programs, but you can create other packages as well. So for doing that, I'm going to create a a folder that it's going to be called calculator, and I can have another function, another file here that it's going to be called calc.go. Again, that could be any name, right? So I'm gonna call this package calculator, and because well, calculator, and because this is not gonna be a main package, I don't have to include a main function here. I can simply just copy paste this, and I'm gonna include it here, right? And I can have that function here in this package, and notice that again works in the same way. It imports the package here in the same way as you were been doing previously, and that's it. Right, so in a typical, and this is where Golang gets a little bit fun, and perhaps if you are new to Golang, you're gonna be a little bit stressed if you don't have a session like this one, right? If you don't know what you're doing. In a typical programming language, you're simply reference this, like import the file here from this other program from this library, and that's it, right? But in Golang, doesn't work that way. I'm gonna be using modules in this case because this is kind of like the new way of working with Golang, right? Because this is an introductory session, I'm not going deeper into that, but the idea is that you can have an idea of how this works, because if you're gonna be seeing other programs out in the internet, this is gonna make more sense. Okay, so I'm gonna clear this, and I'm gonna go to that folder, to the calculator folder, and I'm gonna clear this. So we need to create a model, and to do that, I have to initialize that model. So in this case, I'm gonna do something like go mod init, and I'm gonna do something like github.com my user calculator. So that creates a module, and that creates a go mod file. Notice that that's the name of the module that I would like to use. This is the module that I can use, and this is typically the idea is that you can have this on GitHub hosted with your username, and this is going to be the name of the repository. This is the standard way of working with packages and modules in Golang. Again, as I was saying before, we can continue talking about this for an hour, but that's not the idea. So as you can see here, this is the tree. Then I have these files, and this is going to be the mode where I can specify the name of the module that I would like to use, and that's it, right? So for this one, that's going to be it. In my case, if I want to use this module, if I want to locate it here, let's just one do thing, right? If I do something like run calc go, it cannot run a main package, right? But if I do something like build calc go, that's actually gonna work, right? But it's not gonna do anything, right? Because it's basically just compile that application, and it's not gonna create a package here. In this case, this is not what I would like to do. I would like to reference this locally from another programming language, from another program here, from this hello world. So let's go back to here and do actually the same thing, right? Hello world, and let's actually initialize this this module here. Go mod init hello world, and that's going to be again creating the go mod. Let's actually get rid of this because we don't need it. And again, something similar to the one that we saw previously, right? But in this case, you can see that I'm not doing anything interesting here, right? So if I want to reference here another local package, I mean, I can include this here, other packages if I want to, like any other from any other GitHub repository. But if I want to, I can reference this here in this way to the one that I just created. It's gonna be my user. It's gonna be calculator, and I have to include the version of that package. That's something that actually Golang tried to include it by using modules. And because this is going to be looking for this folder, github.com my user calculator locally, I can actually override that and say that replace this github.com my user calculator, and let's say that I want this to be located at here, calculator, right? And if I do something like this, I can reference this function from that package, and I'm gonna get rid of this, and I'm gonna do something like here, calc, and that should be including this into my import here, right? But because again, this is not something that I have located here, because it says that it does not exist because it doesn't know where to look for it. I have to include that manually here. So let's see github.com/myuser /calculator. And if I store it here, let's see, something I must be done wrong here, right? Calculator, is this the one here? Say here, this is gonna be, let's actually clear this. Well, it should be github.com calculator / my user, github.com my user calculator. I guess that my workstation is not recognizing that yet because I haven't compiled it, right? But if I want to fix that for temporary here right now, I can do something like this, github.com, and I can create that structure, right? My user, and I can create that folder calculator here, and I can simply copy and paste this to here. Let's open this here, paste it, and notice that that's gonna be referencing, that's gonna be included here. It should be included automatically. User calculator. Yeah, well, for some reason that's not working, but if I do something like this, and because VS Code is actually overriding that, right? Because it's gonna be deleting that. If I try to do here, calculator, and I store it here, and I do something like this, and go. Okay, got it. So it doesn't look like that it's gonna work right now. So I can do, oh, actually, let's try to compile it, right? So let's go here to calculator. If I do here, you can see here that I have here the commands that I can use for creating that packages, right? So it says like compile and install packages and dependencies, right? So I can install that package, and I can do go install calculator. It's located here, and let's see if I'm lucky enough right now to include it. And it looks like that it's not gonna work. Guess that I must be doing something wrong that I'm not seeing right now. Yeah, okay, so I guess that time's up. For some reason that didn't work. I guess that I must be missing something that I cannot remember right now because I'm doing this live. Sorry for that. So I'm gonna go back here into fixing that while I wait for someone to ask any questions, if we have any. So fire them if there are any questions.
Yeah, we started to get questions on the chat.
Okay.
So the question is, can you explain why you used an underscore again for string conversion?
Okay, sure. So let's go back here to this. Let's see if I call it here. Okay. Okay. So in this case, I just let's see why it's not working here. Guess that I went too far. Okay. Yep. Call here. Well, in this case, I'm using here to ignore the value here, because if we go back here to that name of the function, let me actually, let's see if I can see the definition of this. Notice that the signature says that it returns an error. So it returns multiple variables here, an int and an error. And I want to ignore that variable. If I don't include this, Go, it's gonna complain and say that the function is returning two values and you need to actually use those two values. But I don't want to use that other value. So the way of me of ignoring that other return value is by using underscore. And that's basically it, but what I wanted to do, and the reason why you use underscore here.